Alright, so now we're going to talk about section 7.3, which are some basic methods of counting. And this is not just going to be like counting on your fingers. These are going to be some ways of counting sets, and they'll be, a little bit more sophisticated than just counting on your fingers and toes or whatever. But it's going to be simpler than some of the things that we're going to see in section 7.4, which are some really sophisticated techniques of counting things. Anyways, as just sort of a motivating example, the first thing we're going to look at is counting unions of sets. And as a motivating example, I'm going to look at Jersey Shore. Can't get me enough Jersey Shore. I'm not lying. Anyways, here's the deal. Jersey Shore, there's a whole, some of them are Italian. And, there's sort of issues about how they represent Italian Americans, but whatever. But not all of the people on Jersey Shore are Italian, but anyways, let me sort of give you a breakdown of people in Jersey Shore. There are 8 people total in Jersey Shore. These are, of course, we have Ronnie, Vinny, Paulie D. Why don't I even just call him DJ Paulie D? The Situation. We have Jay Wow. We have Snooki. There's Sammy, quote unquote, sweetheart, and the last new addition is Dina. Angelina is no longer part of it and hasn't been for a while. Anyways, well, let's take a look at this. How many of these are actually Italian? Well, 6 of these people are actually Italian. We have Ronnie, Vinny, Paulie D, Sitch, Sammy, and Dina. Snooki is sort of an Italian heritage because she was adopted, but technically she's actually from, she's, I think, Peruvian or Chilean or something like that. Anyway, so by ethnicity, she is not Italian. And there are 4 girls who are, you might not be able to tell from the names, but Jay Wow, Snooki, and Sammy, and Dina. So if I were just to say this to you, I is the set of Italian cast members, and F was the set of female cast members. Well, for a set, I'm going to let N of a set mean the number of elements in S. So what we have is the number of Italian cast members is 6, and the number of female cast members is 4. Now, if I sat down and said, well, how many cast members are Italian or, give me a second, or female, you might guess that it's just going to be the number of Italian cast members plus the number of female cast members, and this would be 6 plus 4 is equal to 10. But wait a minute. There are only 8 cast members. Situations Booty Call and Gianni don't count as cast members, even though they show up every now and again. Whatever. No, it's just only 8 cast members. So what happened? We counted 2 people twice. Remember that the set of Italians is Ronnie, Vinny, Paulie, Sitch, Sammy, and Dina. Let's just call her D for short. Whereas the set of females is JWoww, Snooks, Sammy, and Dina. Okay, so we counted Sammy and Dina twice. They're both Italian and female. So we have to subtract them off. Indeed, what we end up with is the number of Italians or females in Jersey Shore, which is all the cast members, is the number of Italians plus the number of females minus the number of people who are Italian and female. Now, Italian and female is just equal to Sammy and Dina. So that means that the number of Italians or females is equal to 6 plus 4 minus 2 is 10 minus 2 is 8. Great, that's what we expected. So the basic fact is this. Let's call this the addition rule. It just looks like this. The number of elements in a union is equal to the number of elements in the first set plus the number of elements in the second set minus the number of elements in the intersection of the two sets. We have to subtract off this piece right here because the guys that are in both A and B are counted twice when you add up A and B. Sammy and Dina got counted twice when I added up the Italians and the females. So I had to subtract them off to account for the fact that they were there twice. I was going to do a little, I was going to draw them instead of draw some circles around everybody and whatever, but I was going to draw them with like identifying features like, Ronnie I was going to draw with, big muscles, and Pauly D with a blowout. Situation you might expect I'd draw his abs, but I was actually going to draw him with a neck brace and sunglasses, and Snooki would get a poof, and Sammy would have a mean-looking face on. But when I got to JWoww, I could only think of one thing to put for distinguishing features, and that sort of put the kibosh on, kibosh, whatever, on doing that. So anyways, no pictures. Okay, let's use this in a couple of more examples. Let's look at this. So let's say E is the countries in Europe, and A is going to be all the countries in Asia. Well, I looked this up. The number of countries in Europe is 50, and the number of countries in Asia is 48. But you may know that there are a number of countries which are actually on both continents. Continents. These include Russia, Georgia, Turkey, and Azerbaijan and Kazakhstan. Did I spell those right? I believe I did. Fantastic. Okay. So what this tells us is that the number of countries that are in both Europe and Asia is 5. So if I ask how many countries are there altogether in Eurasia, Europe and Asia, it's going to be the number of countries in Europe plus the number of countries in Asia minus the 5 countries that end up being in both continents. So that's equal to 50 plus 48 minus 5, which is 98 minus 5, which is 94. So that's 3. So there are 93 total countries in Eurasia. Now, sometimes we use this backwards. What I mean is, if I start with the original rule, we can start with the original addition rule and solve for the number of elements in A intersect B. And what we end up with is the number of elements in A intersect B is equal to the number of elements in A plus the number of elements in B minus the number of elements in A union B. Now this is not so intuitive. It doesn't have a nice description as the other rule, but it's a fact which can be useful sometimes. So as an example, let's look at this. My cousins. I have 11 cousins, and all of them have at least one sibling, brother or sister. Now, let's see. 8 have brothers, and 6 have sisters. How many have both a brother and a sister? Well, then let's say B has a brother and S has a sister. Then the formula above says that the number of people who have a brother and a sister is the number of my cousins who have a brother plus the number of my cousins who have a sister minus the number of my cousins who have a brother or a sister. Well, all of them have a brother or sister, so that's all my cousins. So this is, how many have a brother? 8. How many have a sister? 6. How many have a brother or sister? All of my cousins, all 11 of them. So that's 14 minus 11, that's 3. I have 3 cousins who have both a brother and a sister. So 3 have both a brother and a sister. Cool. Let me note that if 2 sets are disjoint, i.e. if the intersection between the 2 sets is the empty set, then our rule turns into this. The number of elements in A union the number of elements in B is equal to the number of elements in A plus the number of elements in B minus the number of elements in the empty set. But the empty set is empty. That means it has no elements in it. So what this implies is that the number of elements in A union B is equal to the number of elements in A plus the number of elements in B. That is no big surprise. To count the total number of elements, I have 2 distinct groups. How many are there together? I just add the 2 numbers up. So as an example, I have 31 students in 108 section 19, and I have 29 in 108 section 24. So how many 108 students do I have all together this semester? So let's say N is 108 19 and T is 108 24. So the number of guys in 108 19 is 29. The number of guys in 108 24 is, this is 29, this is 31. And the number of people that I have registered for both sections, well, this is the empty set. Now, how many people are actually registered for both sections? None. Nobody is double registered. That doesn't make sense. So that means that the number of my 108 students altogether, the number in 108.24 union the number in 108.19 is just equal to the number in 108.19 plus the number in 108.24, which is 31 plus 29, which is 60. I have 60 108 students altogether. Now, another fact I would like to notice is this. Let's let U be a universal set and let A be any set and A prime its complement. Then we have the following fact. A set and its complement have empty intersections. They don't, because A prime is everything not in A. So no element can be in a set and its complement. But the union of A and A prime is the entire universe, because you're either in A or not in A, and if you're not in A, then by definition you're in A prime. So what this tells me is that the number of elements in U in the union is equal to the number of elements in A plus in the universe is equal to the number of elements in A plus the number of elements in A prime. So we can solve for the number of elements in A prime, and what we end up with is the number of elements in A prime is equal to the number of elements in U minus the number of elements in A. A quick example, I have, 109 students this semester. So how many do I have in 104? It's 109 minus the number of people I have in 108, which is 109 minus 60, which is 49.